Hi, today we've got another question from Professor Povey's Perplexing Problems. This question is called the Intercontinental Telephone Cable. And it reads the following. A telephone company has run a very long telephone cable all the way around the middle of the Earth. Assuming the Earth to be a sphere and without recourse to pen and paper, estimate how much additional cable will be required to raise the telephone cable to the top of 10-meter tall telephone poles. So what this question is saying is, there's a cable wrapped around the Earth, and we need to estimate how much more cable would be needed to have cable around the Earth that goes 10 meters further out. 10 meters. Right. So the way I look at this problem is from on top of the Earth, so a bird's eye perspective. This is the inner circle, and we essentially need to find the circumference. So let's call our radius x, because it's an unknown. Our circumference here is 2 pi x. Now let's look at the outer circle, where the radius is x plus 10. Here the circumference will be 2 pi x plus 10, which equals 2 pi x plus 20 pi. And we want to find the difference in these two circumferences to show how much extra cable will be required. And we can just see that the first circumference is 20 pi less than the second. So our answer is 20 pi. One way we could look at this problem through a more general approach is see the circumference as a function, with the parameter being the radius, CR. And we know the circumference to be 2 pi r. If we differentiate C with respect to r, we have 2 pi. Essentially what this is saying is that for every additional meter of radius, the circumference will be 2 pi more. So we can write that as change in C equals 2 pi, and we can call each meter of radius h. So in this case, h equals 10. H equals 10. The change in circumference equals 2 pi 10, which equals 20 pi. Now, another way we can look at this is using arc length. So we've got inner circle with radius r, and we've got an outer circle that's got a radius h plus more than the inner. We know that the arc length equals radius times the angle in radians. So let's call the arc length, the inner one, I for inner, and then the outer AI. So the inner arc length equals r theta, and AO equals r times theta plus h. So we find the difference of these two, r theta plus h minus r theta equals just h theta. And we know a full circle, that in a full circle that theta equals 2 pi radians. So we have h theta equals h 2 pi, which leads us to 2 pi h. Again, we can just sub in h as 10, and we've got h equals 10, change in c equals 20 pi. We can write, oh, forgot to write change in c. Yeah, and that's the second way we can generalize this. That's all for today. Hope to see you in the next.